The Bible is the very first printed book since the invention of the modern press machine. It is the most purchased and read book in history.
Is the earth ancient, as in billions of years old, or is the earth young? Firstly, we have the birth certificate of the universe, Kent, with the Bible. Right. And we know the Bible says the earth is not billions of years old. But the question is, does the scientific data confirm that same thing?
There is a genealogy in the Bible extending from the very first man to live on earth to the birth of Jesus Christ, which is the most famous person to ever live. As a historical book, the Bible can be used to make a claim for the age of the earth.
There's not that many evolutionists out there willing to defend the idea that humans and strawberries are related through common ancestry, which reminds me, I wanted to ask you, you've done about 375 debates. And so are you telling us that you still don't believe that time, matter, and space came from nothing, life came from non-living chemicals, and you are related to banana plants and walking sticks? You don't believe that yet, Kent?
Not yet. Keep trying, guys. Keep trying to convince me.
Well, that's all we're asking for. We just want to see the best evidence.
Earth, and by using dates given in the Bible, the age of the planet Earth and the entire universe is less than 7,000 years old. But ever since the invention of radiometric dating, this historical information from the Bible has been adamantly rejected by the scientific literature. The scientific community concerned with geological surveys do not agree with the literal interpretation of the Bible, and many Christian denominations have compromised the clear understanding of Scripture and adopted theological views that make the numbers in the Bible figurative. The scientific community who believes the history of the Bible to be literally true and scientifically accurate are considered dangerous to the education system. Radiometric dating of fossils and rocks is considered proven as a reliable method to determine the age of any given rock sample from Earth or outer space. Therefore, by simply learning how the process works, we should be able, under close scrutiny, to think critically about the strength of its reliability in calculating the age of the Earth and of the universe. Let us now ask the question, how does radiometric dating work?
Earth cooled and heat was radiated into space, forming a crust. The radioactive parent elements trapped in and on the Earth then decayed into daughter elements we find today. Today, the ratio of the number of parent to daughter atoms is measured. The decay half-life is then factored in to arrive at a radiometric date for any given rock sample on Earth. This assumption about the past is the foundational rationale for old Earth theories. Many leading evolutionists assert confidently that the Earth and everything in it came about from stars exploding. Some realize, though, that all the physics has not been worked out to back this claim up. Another problem with this idea is that much evidence collected from similar nearby rocky planets like Venus and Mars suggests that they have very cold cores and/or show little radioactive decay. Here we see a chart of the average binding energy per nucleon for each element. The elements are shown on the x-axis by the number of nucleons they have, and the y-axis shows the average binding energy per nucleon for a given element. Light elements are on the left and heavier elements are on the right. Trying to merge any of these heavy nuclei in the chaos of a supernova will always result in less binding energy. They will break up or fission. The larger the nucleus, the greater this tendency, as there is less and less binding energy holding it together. This is the data that causes chemical evolutionists to look to physicists in hope that they will eventually figure out why cosmological theory doesn't match observation. And this is why the United States National Research Council in the year 2000 listed the following as one of the 11 greatest unanswered questions in physics. How were the heavy chemical elements from iron to uranium made? Textbooks and teachers rarely explain this problem.
So with radiometric dating, you can tell if you're high or low in the geologic strata, but you cannot get an absolute age for any given rock sample. So if you radiometrically date a dinosaur fossil or a diamond or a sample of coal or granite rock deep within the crust of the earth and the granitic bedrock, you're going to get ages of millions of years. But if you carbon date a dinosaur fossil, a sample of coal, or a diamond, you'll get thousands of years, which directly contradicts the radiometric dates.
Age in the zircons indicates they are 1.5 billion years old. However, the helium produced by the uranium's alpha decays gives a much different picture. Think of a zircon as a leaking helium balloon. If 1.5 billion years of time has gone by, then the balloon should be empty. However, measurements of the rate of helium loss in zircons indicates that they remain astoundingly full, with data showing that only 4,000 to 8,000 years of helium loss has occurred. If supernova did not cause nucleosynthesis of heavy elements, what did? Where is Earth's radioactivity located? For example, ocean floors are releasing a great deal of heat, however, little radioactivity exists there. In startling contrast, Earth's continents are releasing slightly less heat than ocean floors, yet we find 70 times more radioactivity concentrated on our continents.
Very stable, heavy radioactive elements on low on the geologic column are going to yield great ages. Unstable radioactive elements at the top, because they decay so quickly, they yield only millions of years and not billions of years. You have great ages at the bottom, low ages at the top of the geologic column, because elements up here are unstable. They decay rapidly, so you get only millions of years of decay, whereas more stable elements that decay more slowly, they can yield billions of years of decay. So you have very stable and high great ages at the bottom, and very unstable low ages at the top.
Many believe that nuclear reactions are occurring deep inside of Earth's core, and that the heat released by these reactions is the cause of geothermal heat. Measurements taken in the world's deepest drill holes show that temperatures rise very rapidly with depth. If deep radioactivity from Earth's core is the source of this heat, then the temperature increase with depth would mean that everything below 50 miles would be melted. However, seismic data from thousands of earthquakes show conclusively that the mantle rock is solid down to about 1,800 miles. Carlsbad and Jaeger reveal that while the distribution of radioactive elements in Earth is unknown, the radioactivity must be very shallow, not deep, and confined to Earth's thin granite crust.
So with radiometric dating, you can tell if you're high or low in the geologic column. You can tell if you're in deep strata or in surface level strata, but it cannot give you an absolute age of any rock sample.
So the answer to this first question, Earth's radioactivity is not uniformly distributed throughout Earth, as is expected if Earth evolved. Instead, we see that radioactive elements are concentrated in Earth's granite continental crust. The hydroplate theory will explain why. A plasma occurs upon electrical breakdown of any substance. In this case, the air molecules, mostly nitrogen and oxygen, have been transformed from their normal gaseous state to plasma. This happens as the electrical potential, or voltage, between the clouds and the ground increases above air's dielectric strength. The result is a massive flow of electrons, a current that arcs between the clouds and the ground. After a lightning strike, showers of gamma rays and a burst of neutrons are detected, a result of nuclear reactions and radioactive elements produced by the lightning. So what is happening within the plasma? When electrical current travels through close, parallel wires, a very powerful pinching force is generated known as a Z-pinch. Lightning struck this tube, causing it to be radially compressed or pinched together. The key to seeing how Earth's radioactivity is concentrated in Earth's continental crust is to recognize that the main rock found is granite. Unlike basalt that covers the ocean floors, granite contains a great deal of the mineral quartz, about 27% quartz. Quartz crystals are arranged in such a way that they will produce an electrical potential, or a voltage, if they are stretched or compressed. Such materials are said to be piezoelectric, piezo meaning pressure. Ever wonder how your gas grill can light the propane by simply pushing a button that has no battery? The snap you hear at the end of the button stroke is a spring slamming into a quartz crystal, causing it to compress and give off a spark, igniting the gas. Here's a similar device that allows us to see what is happening without tearing apart your grill. A child could push or pull on the lever and produce enough pressure in the small quartz pellet to produce a 4,000 volt spark. Imagine the voltage produced on a continental scale instead of this display. Some may ask what evidence there is that granite could produce electrical charges. Here are some quotes taken from eyewitnesses around the world. Of course, today, many witnesses have uploaded YouTube videos of these strange lights during large earthquakes.
In fact, if you do a study on geochronology and estimate the age of the Earth using other methods to calculate its age, most of the methods that you can use to estimate an age of the Earth show that it cannot be billions of years.
Willard Libby, 1955, was featured in Time magazine. He's the one that really invented carbon dating back in the late 40s and early 50s. Radiation from the sun strikes the atmosphere, produces radioactive carbon-14. It combines with oxygen to make radioactive carbon dioxide, CO2.
Some carbon that's in your body is carbon-14.
So how do we end up with the carbon-14 in our bodies?
So carbon in nature, add carbon-13 in there too. So carbon-12, stable. Carbon-13, stable. There's not much of that. Carbon-14, unstable.
Unstable.
Carbon-12 is stable. 12 is 6 protons, 6 neutrons. It's stable.
Right.
You add 2 neutrons, it's not stable.
Right.
It will decay.
In a half-life.
In a half-life. And the half-life of carbon-14, if I remember correctly, it's around 5,000 years, which means after that amount of time, half of the carbon-14 is no longer there.
Right.
It has decayed.
So the plants are breathing in CO2 through the stomata, and they're making it part of their tissue.
So here's what happens. When you are alive, you uptake that native amount of carbon 12, 13, and 14 into your body.
Okay.
And it stays at that level, okay, until you die, because then you stop ingesting more carbon. There's carbon in all food you eat, basically.
Right.
All food that has any nutritional value has carbon in it, okay? The moment you die, you're no longer refreshing the carbon. And the carbon-14 then decays.
And then that's when we can figure out the timing.
Correct.
Okay. So it goes from a half to a fourth to an eighth to a 16th. There should be no measurable C14 after 40 to 50,000 years. But ICR and Answers in Genesis both have great articles on their channel, on their website, about diamonds, which should be impervious to carbon-14 transfer. Read their article about diamonds proving C14 is crazy.
Diamonds and layers of strata that have been radiometrically dated to billions of years old have significant amounts of carbon-14 inside of them. There's no way that it could have been contaminated because the diamond is the hardest substance on Earth, so carbon-14 is in the diamond must be less than 100,000 years old, which means that the layer of strata containing the diamond is also less than 100,000 years old.
Anyway, so they make a calibration curve. If it's getting 16 clicks per minute on your Geiger counter, it's still alive or freshly killed. If you're only getting 8 clicks per minute, 1 half-life, 4 clicks, 2 half-lives, 2 clicks, etc. With their short 5,700-year half-life, no carbon-14 atom should exist in any carbon older than 250,000 years. Yet it has proven impossible to find any natural source of carbon below the Pleistocene strata that does not contain significant amounts of C14. Even though such strata are supposed to be millions or billions of years old. Conventional carbon-14 laboratories have been aware of this anomaly since the early 1980s and have strived to eliminate it and are unable to account for it. Lately, the world's best such laboratory, which has learned during 2 decades of low C14 measurements how to not contaminate specimens externally, under contract to creationists, confirms such observations for coal samples, and even for a dozen diamonds, which cannot be contaminated in situ with recent carbon. These constitute very strong evidence that the Earth is only thousands, not billions of years old. ICR.org.
The Bible says that the Earth is less than 7,000 years old. Radiometric dating is supposed to disprove that. The troubles of radiometric dating are undeniably deep and serious. They allow for contamination here, fractionalization there, and collaboration whenever possible. It is a fix-it-as-we-go approach to science. Fully half the dates in any radiometric dating samples are rejected, and the other half are published by a selection of which ages better fit their theory. The dates that are selected are based on gross discrepancies of a chronology that is uneven and relative. The whole blessed thing is nothing but 13th century alchemy. It's why you can date a living snail and get a carbon date of 27,000 years old, according to Science Journal.
Radioactive dating would not have been feasible if the geologic column had not been erected first. American Journal of Science.
If they didn't already have ages assigned to these layers of strata, then the radiometric dates that are selected would not be feasible.
Apart from, let's see, ever since William Smith at the beginning of the 19th century, fossils have been and still are the best and most accurate method of dating and correlating the rocks in which they occur.
The way that you know the age of a fossil is by radiometrically dating the rock.
Apart from very modern examples, which are actually archaeology, I can think of no cases of radioactive decay being used to date.
And when you date the rock, you're going to get several results in the geochronological laboratories, and they select the results that are closest to the theoretical ages of the fossils that were in the layer of strata that you got the rock sample from. But there are some assumptions in radiometric dating. The assumptions are the rate of decay of the parent isotope and the absence of added radioactive material. The longer the half-life of an isotope, for instance, the wider range of error in its measurement. There are errors in this method of calculating an age of the Earth. Because sedimentary rocks have multiple origins, the radioactive materials in them can have a mixture of ages. Radiometric dating, this gives you an absolute age, but that's absolutely false. They don't yield absolute ages. There is no possible way that you can get an absolute age using radiometric dating techniques. A geologist at the Berkeley Geochronology Center used the most advanced techniques to date human fossils. He reevaluated a Homo erectus skull found in Java in the 1930s. He tested the sediment that they were in. The erectus was thought to have vanished 250,000 years ago, but he was using two other methods of radiometric dating and got a carbon date of 53,000 years at the most and no more than 27,000 years. There was a professor that lied about the age of the Neanderthal skulls and artifacts for 30 years. A university panel exposed his frauds and he resigned in 2005. He had dated the Bischoff Spire skeleton at 21,300 years old, but testing at Oxford showed them to be 3,300 years old. The same research shows that he dated a skull from Germany at 27,000 years old, believed to be the oldest human remain found in the region until the Oxford investigations indicated it belonged to an elderly man who died in 1750. In this book on human evolution, it says in the last 2 years an absolute date has been obtained for the Gondong beds above the Trinal beds, and it has a very interesting value of 300,000 years, plus or minus 300,000 years. That sounds real accurate. Living penguins dated at 8,000 years old, plus or minus 8,000 years. If you were to just take a sample of rock that had a dinosaur fossil embedded into it and send that to a laboratory, it would come back with a carbon date of 20 to 30,000 years, and some other date using another radiometric dating method. If the sample is not identified as a dinosaur in advance, you're going to get the wrong age every time. Google says that radiocarbon dating does not work well on dinosaur fossils because of the presence of contaminants. Organic contaminants like glue used during excavation can cause a false young radiocarbon date. Bone minerals in Mesozoic dinosaur fossils can accumulate new radiocarbon through recrystallization, resulting in a falsely young radiocarbon date. According to Google, despite these issues, evidence from other isotopes showed that dinosaur fossils are millions of years old. So if you use different methods of radiometric dating, they will yield an accurate age of millions of years old for the dinosaur fossils. But you can't carbon date a dinosaur fossil. You have to use other methods of radiometric dating.
Geiger counter will pick up the clicks as it falls apart. Click, click, click. Radioactive, like uranium and other elements like that. Radioactive C14 is being produced in the atmosphere by the sun and the stars. It breaks down to nitrogen at the rate of half of it every 5,730 years.
And then you wait another 5,700 years, half is gone again.
Right.
You wait another 5,700, it's half of a half is an eighth.
If the atmosphere is 0.0000765%, you probably are too, but it doesn't work out that way. When the plant or animal dies, it stops taking in new C14. It stops eating and breathing, obvious. So they're comparing the amount of carbon-14 in the object they're dating with the amount currently in the atmosphere. If it is giving you a reading of 0.0000765, it's freshly killed. If it gets half of that much, it's 5,700 years. 1/4 of that, 1,400 or 11,000 years. 1/8 of that, 17,000 years.
Right.
So you keep doing this, and you know what it does? It gives you access to dates across all of recent human history. From when we were in caves, up through recorded history, right on up back through 1,000 years ago, 500 years ago. So it's very useful for dating life on Earth.
We actually find helium inside of rock crystals. Now, helium actually slips out of the rocks over time. And so I suppose you've probably seen, rock crystals that actually have air bubbles inside of them. And those air bubbles are actually helium. And over time, that helium will slip out.
They have also found helium deep within the granitic bedrock of the crust under intense heat and pressure, being that far down in the earth. Okay, it's under a lot of heat and pressure from the overlaying burden of heavy rocks.
According to evolution, the Earth is 4.5 billion years old. And so to say that helium has been sitting inside of rock crystals and has not slipped out by now, after 4.5 billion years?
There are zircon crystals within the granitic bedrock, and they have helium in them, which it has been studied, and it has a retention rate. So the helium has been depleting for 4,000 to 5,000 years, escaping the zircon crystal, but the radiometric date for the granite rock that the zircon crystal is contained in is billions of years.
If I was to go into a garage where we have an air compressor, and you know how the air compressor has to kick on to recharge every once in a while, the air cannot stay compressed in there over time. And so the more time that the air sits in the air compressor, the more it's going to have to recharge because the air will slip out. Well, same thing with rock crystals. It cannot be there from billions of years ago because that air would have just simply slipped right out of the rock and there wouldn't be any helium inside of these rock crystals. And so just as in a garage in an air compressor, you have air that slips out over time, helium slips out of rock over time. Nobody would ever say that the compressed air has been sitting in an air compressor for billions of years. And just in the same manner, nobody would ever say that helium inside of rock crystals has been sitting there for 4.5 billion years.
However, because helium is the lightest element in the universe, other than maybe hydrogen, it escapes very easily, so it cannot be retained in the zircon crystal for billions of years. And so does the helium retention rate in zircon crystals, showing that the helium cannot be contained in granite under that much pressure for billions of years. It's one of the lightest elements. These directly contradict the ages that radiometric dating techniques are giving.
So let me give you some concrete examples. Some of you, for this, may be revision, but that's fine. Mount St. Helens, when it erupted in 1980, after that eruption, a new lava dome started to build inside the blown-out crater. And we could actually observe these form. And my friend and colleague Steve Austin went up and got some samples from lavas in the lava dome whose age we knew by observation. We knew that the lavas had formed, had flowed out of the volcano, the molten rock had crystallized and cooled back in 1986. And in 1996, the samples went to the laboratory. So the rock from observation was only 10 years old. So what results were obtained? Potassium argon ages range from the whole rock at 0.35 million years up to one of the minerals, pyroxene, gave an age of 2.8 million years. That's one of the minerals in the rock that was separated.
It's composed of 2.6 billion cubic feet of lava, and it's quite young, having finished forming just over 30 years ago. Well, in 1996, geologists sent rocks from the lava dome to be radiometrically dated. Now, they used a method called potassium argon.
Why did it give such large ages?
If radiometric dating and the assumptions that it's founded on were accurate, well then Mount St. Helens rocks should have yielded very young ages. After all, the rock was merely about a decade old. You see, the problem is, they didn't. The rock gave an age of 350,000 years.
Why did it give such large ages?
When they dated the minerals within the rock, the problem got much worse. They gave dates of 2.4 million years.
If a recent lava flow, a recent eruption, a recent lava flow, where we know the true age of the rock from observation or historical evidence gets the answer wrong using the potassium argon method, how can we trust it on ancient rocks where we don't have the historical documentation?
Scientists have taken samples of ash layers that were developed from a volcanic explosion. Within 100 years, they collected the sample of ash, sent it to geochronological laboratories to be radiometrically dated, and they got a range of ages that were with, hundreds of thousands to millions of years old. But the ash layer was recently deposited, and if you do a study on this, you'll find out that no rock sample of a known age has ever been dated accurately using this. If you send a rock sample to a laboratory and they give you an age back, send the same sample to another laboratory and you're going to get a different age every time, because the dates have to be selected. They're not just accepted dates, like that's just you send it to the laboratory and then you get a result back. There's all sorts of problems with this, all sorts of assumptions, and no rock sample of a known age has ever been dated accurately using this method, which means that if you know the age of the rock sample, the method is assumed not to work. But if you don't know the age of the rock sample, the method is assumed to work. That's like saying that my calculator only works with small numbers, it doesn't work with big numbers.
We are commonly taught that the Earth is made of stardust, leftover star material that was expelled from a supernova. This assumption gave rise to the idea that radioactive decay of certain elements created by these stars, another big assumption, could be used to measure the age of the Earth. Earth's radioactivity is often cited as the reason why Earth has not completely solidified over billions of years and why there is much geothermal heat coming up from below. While that may seem like a satisfactory explanation for these issues, There is much contradictory evidence. In fact, the lightning we see during a storm gives some clues to the remarkable origin of radioactivity on Earth. The hydroblade theory will further show that the root cause behind this radioactivity is uniquely explained by the extraordinary conditions produced by a global flood.
This system does not work at all. It's completely broken and idiotic. If you're going to use it for anything other than being able to register whether or not you're in surface layer strata or deep within the crust of the Earth, where there is a lot of uranium and lead, which is producing billions of years of decay. It just tells you if you're in low levels of strata where there's stable radioactive elements that can last for billions of years, or higher in the strata where there is a lot more unstable elements that abound higher up in the strata, and these decay very rapidly, so you're going to get young ages appear because you have unstable elements that abound at the top and more stable elements that abound at the bottom.